Today's lesson is how to complete congruent triangle proofs. Now, the proofs in this example, they're a little bit more difficult than what we've done in class, and that's okay. So what you're doing is you're kind of learning a harder property, harder theorems. It's not a big deal. We still use the same things that we've done before. The trick to these, though, since it doesn't give you the end, you have to draw on your picture. Please draw on your picture. I cannot say it anymore. You have to draw on your picture. Math is hard, but when you draw on your pictures, it's easier. So the first thing, I noticed that my reasons here should be given. That is a clue for me to immediately look at my problem and copy and paste the given exactly how I see it. So I never manipulate the given, ever. So one line is given, the other line is given. So all you're going to do is separate it. So segment AC is congruent to segment BC. I'm going to pause, look at my picture, and say, okay, is AC and BC marked on my picture? No. So to show AC is congruent to BC, I'm going to go ahead and draw here. Draw on your picture. It will help you. All right, next. My next part is D is the midpoint of AB. Now, I hope as I read that sentence that your mind set off a little reminder, hey, I hear a vocab word. When you hear vocabulary, define it. That's why they're giving you the vocabulary word. It's helping you add a piece to the puzzle. If you recognize vocabulary and remember what it means, you'll be able to do all of these problems, no matter how complicated they look. So my next line, my little hint is that I want some things congruent to each other. Well, in my brain, I saw the word midpoint. The next thing I got to do is use the definition of it. When you see vocabulary, define it. So D is the midpoint of AB. Well, if D is in the middle of AB, that means that this segment is congruent to this one. So segment AD is congruent to segment DB, right here. And that's using the definition of midpoint. The next thing my mind should go to is kind of what triangles I'm focusing on. So this says, prove triangle ACD. ACD, that's this triangle. Prove that that triangle is congruent to BCD. BCD. So we're trying to prove these two triangles congruent. My mind should see that these triangles are side by side. When I have triangles that are side by side, that means that they share a side through the reflexive property. So I know for a fact that I can put 3 bars here because ACD is congruent to CD. CD is congruent to CD, and that is the reflexive property of congruency. And the reason we write CD twice is not because we're just being repetitive. It's because one line of CD comes from the triangle on the left. So if I were to cover up this one, CD is still there. The other CD comes from the triangle on the right. If I cover up the left one, the right one is still there. So that's why we write CD twice. And the best way to help you remember reflexive is to think of the word reflection. When you look into the mirror, your reflection is looking back at you. So when CD looks into the mirror, it sees CD back. So reflexive property means that it's the same on both sides. Now, we're going to analyze our picture. Bars get S's, angles and curves get A's. So I'm going to put an S, 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 and S. Hopefully we notice immediately that this is side, side, side. So when I show that this triangle is congruent to this one, I'm going to prove that using side, side, side. You would not notice that unless you draw on your picture. Please draw on your picture. Okay, let's take it up a notch, and so let's do one completely blank. The one good thing about this problem is it tells you that there are 6 lines of proof. So that's pretty useful. Okay, here we go. Given PR bisects angle QPS and angle QRS, prove PQ is congruent to PS. This is different. We briefly talked about this in class. We are going to be using CPCTC. Okay, so I'll write that right here, C, P, C, T, C. And we'll go back over that in just a minute. But in order to get this, this stands for corresponding parts of congruent triangles are congruent. In order for all the pieces to be congruent to each other, you have to find that the triangles are congruent. So in this final proof, the proof goes last. Our last step is always going to be segment PQ is congruent to segment PS. Our reason will also be CPCTC. When we're dealing with congruent triangles, okay, when we're working with congruent triangles, once you prove the triangle is congruent, you can prove that their corresponding parts are the same. Our next line of proof is going to be us writing the given. So again, step 1, I am not going to create any form of equation. Even though my mind should see the word bisect, I am not going to make an equation no matter how hard I want to. I need to make sure that I write the given exactly how I see it. So in this problem, I'm just going to copy and paste. Segment PR bisects angle QPS and angle QRS. The reason is given. What's happening in this problem is we have a double angle bisector. So I need to make sure that I'm being smart about this and looking at my picture. I'm never just going to assume that I know what I'm doing. I'm going to make sure that I have information and facts to back up my philosophy. So PR bisects QPS. Let's focus here first. QPS, PR is cutting it in half. That means that this angle and this angle are congruent. Bisect means to cut in half. So my next statement is going to be that QPR, angle QPR, is going to be congruent to this one, SPR. My reason is the definition of angle bisector. And you want to be as specific as possible. We don't just want to say definition of bisector, because what are you bisecting? We're cutting angles in half, so we want to go ahead and make sure that we write angle bisector. Well, segment PR also bisects angle QRS. QRS is located here, which means that this angle and this angle are now the same. So I'm going to just write that sentence. Angle QRP is congruent to SRP. Notice how we have the same vertex in the center. We have the P's up here and the R's down here. You are allowed to write the definition of angle bisector again. It's okay to have the same reason back to back. Immediately my mind should go to, okay, these triangles are side by side. That means they have to actually share a side. Side PR. So segment PR is congruent to segment PR. And remember, it's called reflexive property of congruency. Now I have enough on my picture to determine that the triangles are congruent. So looking here, I'm going to go ahead and make sure that I'm labeling curves get A's, bars get S's. So regardless of which triangle I'm looking at, I should be able to see that this is an angle side angle. Okay. And then I'm just going to name it. Triangle PQR is congruent to PSR. Remember, you have to follow the pattern once you create it. Now, this is way more complicated than what the state test requires that you do. So if you can follow this proof and kind of understand the thought process, you'll be just fine on the state test. As far as the state test is concerned, it's mostly just drag and drop when it comes to proofs. So they'll probably have this whole proof complete except the angle side angle part. So if you draw on your picture, you'll be able to select the right answer. So don't feel overwhelmed if this problem intimidates you. It is way harder than what you're going to have on the state test. And remember, I'm doing that for a reason. The purpose of it being more difficult in class is so you feel more confident on the test. So if this scares you, don't be scared of it. As far as the state test is concerned, as long as you understand these reasons, once these are in order, you'll be good to go.